Hey everyone, today we are going to look at key features of our graphs. There are a few of these key features that we've looked at already, so we're going to do a quick review on these domain, range, x-intercepts, and y-intercepts. So the domain are all possible inputs. They are x values. For this parabola that I have down here, the domain is all real numbers. Those arrows are pretty important, meaning that they will continue forever. And it will get wider and wider slowly, but it will go to the left and right forever, which means that it'll go all the way out to like a negative infinity out here and a positive infinity out on the right. It goes and covers everything. So all real numbers. The range has to do with y values. The range does not hit all y values. There are some y values up here that the graph definitely will not touch at all. So the highest y value that it hits looks like is up here at -2, and it hits everything below that. Now, we count 1, 2, 3, 4, 5. We count from a lower number to a higher number. And we're going to do the same thing here. I'm going to go from the lowest, which again, the arrows, it's going to go down forever, down to negative infinity. And I'm going to go from negative infinity up to my highest value, which again is -2. I cannot include the negative infinity, so I have to have the parentheses there. It does actually hit the -2. There is an actual point there, so I will include the -2 with a square bracket. And then we've got x-intercepts and y-intercepts. X-intercepts are the points that are on the x-axis, which in this case, here's my x-axis. The graph didn't actually hit the x-axis, so I have no x-intercepts. The y-intercepts are points on the y-axis. So here's our y-axis, and it looks like it hit the y-axis once at this specific point right here, 0, -3. Here are a few key features that we've seen before. Let's look at some new key features. We've got increasing, decreasing, and constant. So I'm going to give like a very mathematical description, and then I'll kind of tone it down into a more common vocabulary. A function is increasing on an interval when for any x1, x2 in the interval, x1 is less than x2 implies f of x1 is less than f of x2. Okay, so what does that even mean? First of all, an interval, we're going to see lots of intervals. Intervals are going to be from where to where. So a lot of times we use either parentheses or brackets, but it's going from that first number to the next number. And then again, parentheses would mean that that number is not included. And then the square bracket means that number is included. For our increasing section here, it looks like this is my x1. This is the first x value. And you can pick another x value, but it has to be after this. Maybe my x2 is like 5, and 5 hits up here. It is increasing on this whole section. Your x1 has to be less than x2, which is true. My 3 is less than 5. And then your f of x1, f of x is a y value. So f of x1, it's like my first y value. So this right here, where my x1 hits, is going to give me my y1. Again, you can call it y1, or it's an f of x1. Up here, it hits another y value, or you can call it f of x. So this is like my f of x2. What they're saying is you're going left to right, and then f of x1 is going up to f of x2. It's saying as you go left to right, your y value should be increasing. That's why it's called an increasing section there. Decreasing, still going to have an interval. Your x's still go left to right. So here's like my x1 and my x2, like -5 to -4. And in this section, my y values are now decreasing. I'm still going, again, left to right. And it is decreasing as I go left to right. In your interval, make sure you always put x1, like the lower x value, comma, and then x2. And then constant means it's not increasing, it's not decreasing, it is the same y value all the way through. And so you have some first x and x1, some second x, x2. Between those x's, it should be totally constant. So let's see if we can apply that here. On our graph, it says find all increasing, decreasing, and constant intervals. So on this particular graph, if I read left to right, it is increasing. It's going all the way up to the vertex here. My increasing interval is going to be from negative infinity. It's got that little arrow on here, like it goes on forever. Negative infinity up to the x value that it stopped at, which was the x value 1. Remember that a square bracket means that that number is included, and I did not include the 1. That's because it is neither increasing or decreasing here. It is not included in any of the intervals. This interval was my increasing interval. The decreasing interval, again, I still read left to right, and from the x value 1 on forever, it's got the arrow, goes to infinity. So from the 1 to infinity, it is decreasing. Notice that again, I did not include the 1 or the infinity. They have parentheses on them. They were not included in the increasing or decreasing interval. And as far as constant goes, there is no totally flat constant part on this graph. So I have no constant interval. All right, so those are some key features along with a relative minimum and a relative maximum. So again, let's take a look at their technical description and then we'll kind of tone it down a little bit. So a relative minimum is an xy point where a function changes from decreasing to increasing. The relative minimum is lower than the point on the left and the point on the right. So here's a few examples. Here's a relative minimum, and it has you kind of zoom in. So just look at the part that I circled. Just a little bit to the left is higher than the point. The stuff on the right is a little higher than that point. Both left and right are higher than this point. For that reason, it is a relative minimum. Same thing for this point as well. If you kind of zoom in, just look at that little section right there, really close to it, to the left is higher. Stuff to the right, really close to it, also higher, which makes this point a relative minimum. And very similar to a relative maximum. So if you zoom in, just look at stuff really close to that point, on both sides, they are lower than that relative maximum. And there are 3 examples of a relative maximum on this little graph right here. First of all, it is an XY point. So if I'm finding all relative minimum, relative maximum points in my example here, then I've got this point right here, which is a maximum. If I go to the left, if I go to the right, they all go down on both sides. And it's an XY point, in our case 1, -2, and I don't have a relative min. Because of these arrows, it will continue going down forever to where I don't have a relative min. Okay, so let's look at this example that kind of puts it all together. Find the domain, range, x-intercepts, and y-intercepts. Those are what we did at the very beginning. The relative minimums, relative maximums, and then increasing, decreasing, and constant intervals. Now on this graph, they've kind of labeled all these key points for us, which is great. If you guys get a problem where these points are not labeled, I would suggest putting it in like a graphing calculator, or you can do it on like Desmos or GeoGebra, graph them, and then see if you can trace and find an estimate of these key points. I'm going to start with domain and range. The domain has to do with all of the x values, and again, keep in mind these little arrows. It goes on forever, which means that for my x values, it does slowly but surely get wider and wider on both sides, meaning that my domain is all real numbers. And the range, again, the y values, because it will continue up and down, it hit everything in the middle, so we've got all real numbers for our range as well. The x-intercepts, so where we hit our x-axis, here's our x-axis here, we have hit 1, 2, 3 different times. There are 3 different x-intercepts. So let's write these points here. -1.880. Okay, there's this one. The one in the middle there is 0.350. The last one is 1.530. Now, I hope you guys noticed that the y value is 0 on all of these. It's just different x values for your x-intercepts. And then for the y-intercept, so here's my y-axis, it hit once right here at the point 0, -1. All right, and then we need to find our relative minimum and relative maximum. Again, a minimum or maximum is kind of zoomed in. You're looking at a specific point and just really close to it, the things on the left and right of that point. So let's see, as I read left to right, okay, it's decreasing, decreasing. Oh, and then it bounces up. It's now increasing. Okay, so let's look at this point right here. So a little to the left of it is higher, a little to the right goes higher, which means that this point is a relative minimum at the point -1, -3. All right, and again, it's because I'm reading left to right. I got one of those minimums. Keep it going. Oh, it bounced down again. Okay, so at this point, a little to the left is below the 1, 1. A little to the right is below that point 1, 1. They're both below it because this is a relative maximum. All right, so for my relative max, I've got the point 1, 1. We got to look at increasing, decreasing, and constant intervals. Again, I'm going to read left to right, and as I'm going left to right, I am decreasing. I'm falling down, 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 down until I get to that min, and it bounces back up. So this whole section right here is decreasing, and it's got the arrow on there. So for my decreasing interval, I'm going to go from left to right. And on the left side was that arrow, like it's going from negative infinity to, and it stopped at this x value, -1. So negative infinity to -1. And then I'm going to pick it up from there. It is now going up. It's increasing all the way up until this point, from the x value of -1 to the x value +1. So -1, +1. I always go from the left to right, the lowest number to the highest number. So from -1 to 1. And then once we pick it up from there, it is now going down, decreasing. And it's got the arrow, like it will go forevermore, be decreasing. If I write this from left to right, it was the x value 1, and then forevermore to infinity. Keep in mind that the parentheses on your increasing and decreasing intervals, it's not giving you an xy point, it's an interval. And then these ones also have parentheses, but these are xy points. So we kind of have to recognize what the parentheses are telling us about, and that's based on what information it's described as. So if they're saying it's a relative minimum and maximum, then it's got to be xy points. Now I've got x-intercepts and y-intercepts. These have to have xy points. It's not an interval. But when I say increasing or decreasing intervals, those are the ones that are saying from where to where. I hope this went well, and if you guys have any questions, let me know.